Hello guys, my name is Dylan, my YouTube channel is DRG Bros, and today we are going to be doing Numerical Integration 2. So as usual, topic 1 is our review. So as we learned in the past couple videos, there are two types of common integrals. We have definite and indefinite integrals. So definite integrals have limits, like this one is from 0 to 1 x dx, and then these give us numbers, but these numbers is what is the area under curve. And then there are definite integrals. And definite integrals have no limit. And these give us formulas. And we can use these formulas to figure out the area under curve. So there are other integrals, such as double integrals. So in general, a definite integral looks like this. Dx, and then this equals, now we're gonna want to draw this kind of big, and this is gonna be our area, and then this is the area under the curve, and so this is B. Now the curve continues on. That is B. This is A. So we have B and A here. And so what we can do to determine the area under curve is we can draw some rectangles. So here, we can draw a rectangle, and then we go where the curve starts. So let's go here. You're gonna have to move A in this case, but so A is here. So we can draw these rectangles, and we can figure out the area of a rectangle, which is the length times the height. And we can use that to determine the area of the rectangle, which we can use to determine the area of a circle. So this is f of x. The curve is f of x. But so what we can do is we can label this line x1, x sub 1. And then this can be labeled x sub 2 and x sub 3. Now we only drew 4 rectangles, but you can make them smaller and smaller so that you can get maybe x5 and x6. But so b equals x sub 4. And so this entirety is equal, so this is a, so instead of x, it's x sub 4. So what we can do is we can replace all of these with their proper thing. So this x, or f of x third, x sub third, and then f of x sub squared, and then f of x sub 1. And then these all are the same length, so these could be delta x. It could be represented as delta x. So delta x, delta x, delta x, and delta x. So the integral of a to b fx dx I'm trying to put them in parentheses. Dx is approximately, that's what this line means, is approximately equal to the area of rectangle 1 plus the area rectangle 2, so on until the area rectangle of 4. And so this equals f of x sub 1 delta x plus f of x sub 2 delta x, and then so on until fx4 delta x. So this is topic 1. Let's move on to topic 2. So for topic 2, we're going to do partial sums 2. So let's review over some sequences. So we have 1, 2, 3, 4, etc., etc., etc. And this is an arithmetic sequence. And then we have 1, 2, 4, 8, etc., etc., etc. And these are geometric. And then we have the Fibonacci. But I'm going to add one new one you haven't seen yet. And this one is 1, 4, 9, 16, 25, etc., etc., etc. And so this one is we can write this as we can figure out what the pattern is by saying a sub n equals n squared. So the second number in the sequence is 2 squared, which is 4. And that is how we can figure out what this is. It's basically just squared. Like squared by the number of the sequence that you're in. And so what we can do is we can say S sub n equals 1 plus 2 plus 3, etc., 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 until n. And then this equals k equals 1. And so this also equals something that is from last episode. And so now I'm going to show you some visual proof that this works instead of using arithmetic or algebra. So what we can do is we can put a square. Now this looks more of a rectangle, but let's just say it's a square. And so this is 1. But now what we can do is we can put 2 squares, which again look like rectangles. And this is 2, because there are 2 rectangles. And then we can make 3 rectangles, or 3 squares, but they're rectangles. They look like rectangles, so I'm just calling them rectangles. It's just straight on rectangles. And so this is 3. But so what we could do is we could essentially flip this over, and but this time instead of using rectangles / squares, we're going to use stars. So this is 4, but then this has 4, and then this has 4 as well. And so what we can essentially do, I'm just going to move these down for visual purposes, is what we can do is we can turn this into one giant rectangle. I mean, this does kind of look like a square, but let's just say it's a rectangle. But so the entirety of this thing, this rectangle, is always 4, because there's always going to be 4 things in each column. And so that's the height of the rectangle, and it's always a length time. That's the width, and it's always length times width. So the length is always going to be 3. So we have is 3 times 4 over 2. Or divided by 2. And so this is going to give us 6. Which is the exact amount of the rectangles and the stars. So it's always going to tell us how many rectangles and slash stars there are if we just flip it over. But what we can do is we can draw another rectangle. And then this time we're going to do n, and then n plus 1. But so what this is going to give us is n plus 1. N times n plus 1 over 2. So let's move on to our third and final topic now. And this is going to be sums of powers of n slash natural numbers. So I am going to write down 3 sequences. So we have 1, 2, 3, 4, 5, and 6, etc., etc., etc. Or let's just leave it at 5. But then we have 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc., etc., etc. And then we have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, etc., etc., etc. But then we can also do this with the formula that we had before. So we can do S sub n equals 1 plus 2 plus 3 plus 4, etc., 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 until we get to n. K plus k equals 1, and then this equals our formula n plus 1 over 2. But what we can do is we can do Sn equals 1 squared plus 2 squared plus 3 squared plus 4 squared till you get to n squared. And this equals k squared. K still equals 1. And now I probably should have gone down a space so I didn't run into that problem, but then this is going to equal 2n plus 1 over 3 times n plus 1 over 2. And then for the third one, we're going to do S sub n equals 1 third plus 2 third plus 3 third plus 4 third, etc., 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 until we get to n third, or n cubed. And then k cubed. This is gonna equal n plus 1 over 2 squared. And then one more thing, if we have 1 plus 8 plus 27, but so in the pattern, and then this is going to equal 6 cubed and so this adds up to be 36. But then this is 6 to the 6th power, which then equals 36. So 36 equals 36. Thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.